In this next series of lectures, we're going to look at a special kind of a sequence called a difference equation. And we'll see some of the ways that these systems can be used to model real-world situations. Suppose we have a sequence which you can think of in practical terms as a set of values collected over time. For example, the population of salmon in the North Atlantic, or maybe the value of an investment. And we're going to define the first differences of the sequence to be a new sequence formed by taking the difference of successive values. Now, it may seem a little odd to have the nth difference be the n plus first term minus the nth term. You might reasonably think, well, shouldn't it be n minus a sub n minus 1? But I think it's a little clearer if you think of this nth difference as how much the sequence changes or grows during the nth time interval. All right, so to illustrate this, we can use these differences to model a real-world situation. So take a look at this basic investment. Now, you may have immediately recognized this as a compound interest situation, and you would be right? You might even already know the compound interest formula. But when you're looking at a new concept, right, it can be helpful to start off with a situation you're already familiar with, since then you can focus all of your attention on the new concepts without having to also worry about understanding kind of the underlying scenario. So with this investment, the nth difference is the difference between two successful values of the account, which is equal to the interest earned during that period. And the interest earned, we know what this is. This is equal to 3% of the current value of the account. That is, it's 0.03 times a sub n, right? That is the change in the account, and that equals the difference of two successive values. All right, now notice that I've removed the delta part of the expression, and we're left with something that we can solve for a sub n plus 1. If we move this a sub n over to the other side, this becomes a sub n plus 1 equals 1.03 a sub n, right? And this leaves us with a formula for the value of the account after n years, or putting it another way, the value of the account at the beginning of year n plus 1. Right, now this equation that we ended up with, combined with an initial value, right? We do have to also specify where we're starting. That's this $1,000 here, is what's called a difference equation. So we've got kind of the formal definition here. A first order difference equation is defined as a sequence where each term is a function of the previous term and possibly the number of the term. Right? The first order part means that each term is defined only in terms of the previous term of the sequence, and possibly n as well. More complex versions of these equations can be defined in terms that go further back in the sequence than just the most previous one. So now that we've seen what a difference equation is, we've seen an example of what one is, in the next lecture, we're going to continue with this example. We're going to explore the relationship between the difference equation, the recursive definition, which is what we saw there of this sequence, and an explicit formula, that is a formula that's defined strictly in terms of n, like the sequences that we saw earlier in this chapter.